Assalamualaikum warahmatullahi wabarakatuh. Today we want to present about cat breed identification using machine learning in AI presentation. Next. Before we go to the introduction, I will our teammate. So first is Ahmad Iqbal bin Yaakob. Second is me, Muhammad Nur Azim bin Abdul Halim, and third is Muhammad Alif Ruzaimi bin Razali. Next. So the introduction of our project is we want to identifying cat breed from image is a common challenge in computer vision. This project focus on creating a machine learning model to recognize four cat breed, which is Persian, Maine Coon, British Shorthair, and Siamese, using a convolutional neural network, which is CNN. These breeds have unique features like fur, body shape, and face structure, but the differences are subtle and hard for a computer to learn, especially with varied image condition. The model can help veterinarians, animal shelters, and pet owners easily identify cat breeds, especially for recording keeping and lost cat identification. The project highlights key AI challenges such as working with small datasets and detecting minor differences, while demonstrating the effectiveness of deep learning in image classification.
The objective of this project is to design and train a convolutional neural network (CNN) that can automatically recognize and classify cat images into four distinct breeds: Persian, Maine Coon, British Shorthair, and Siamese. This classification can serve in various practical applications, such as pet breed identification, adding animal shelters with automated record keeping and providing educational tools for cat exercise. Next is input data. The input data for our CNS consists of digital cat images collected from sources like Bing, Google Images, Unsplashes, and Pixels. These platforms provided a wide variety of images, ensuring diversity in representation and backgrounds. Each image was manually reviewed to confirm its breadth and quality. To standardize the data for neural network input, all images were converted to JPEG format and resized to 100 times 100 pixels, maintaining three color channel RGB. So with 200 images per breed, the total dataset size is 800 images, which ensures robust trading and validation. Next, we have output classes. Our CNN will classify images into four output classes based on the breed. Each breed is represented by 200 images, providing a balanced dataset for model trading. And next, we have segregation of data. To evaluate the model effectively and avoid overfitting, we split the dataset into two parts: 75% for trading and 25% for validation. This ensures that the model can learn effectively from the training data while being accessed or unseen images during validation, maintaining the integrity of each class distribution in both sets.
So today we are going to show our 10 experiment. So for our first experiment, we are using filter set of 1632. We are using optimizer which is SGDM and the learning rate 1E minus 3. For the rest, we don't use it. So we are going to run our first experiment. So the input size for this dataset is 100 by 100. We are using 3, okay, for the RGB. Alright, so this is our training progress for the experiment 1. where as you can see we have 216 iteration. This is because we have 12 epochs and we have 18 iteration per epoch, and we validate our data for each 50 iteration, so we have learning rate of 0.001. So we are going to wait for this experiment to finish. Our first accuracy for the experiment 1 is 60%. So 60% is our first experiment. Next we are going to do experiment 2. So our hyperparameter is 1632 SGDM, but we change the learning rate. And everything else is the same. So we are going to run experiment 2. Okay, so as you can see here, the learning rate is changing, but everything else is the same. So we are going to wait for this training progress to finish for the experiment 2. So as you can see, we get 57.15% for our experiment 2. Next we are going to be running experiment 3, where we're using 163264 for our filter set. We enable the dropout and we use the learning rate of 1e-3, but the optimizer is the same. So we are going to run the experiment. So this is our learning rate, which is 0.001, and everything else is the same. So we are going to wait for this experiment to finish. So we get 67% for our experiment 3. As we are going to move on to experiment 4, which we're using 163264 filter set. We disable the dropout, so everything else is the same as experiment 3 except we disable the dropout. So we are going to wait for this experiment to finish, and then we are going to see what's the accuracy that we get for this experiment. Okay, so we get 65% for our experiment 4. Next we are going to do experiment 5, which we using 163264 GDM 5e-4 for the learning rate. Everything else is the same, so we do not use L2, we do not use dropout, we do not use augmented data. So we are going to wait for the training to finish, and as you can see here, our learning rate for this experiment is 0.005. We get 68% for the experiment 5. Next we move on to experiment 6, where we're using ADAM for the optimizer, and we're using 163264 for the filter set and 1e-4 for the learning rate. Everything else is the same. We do not use L2, we do not use dropout, we do not use augmented data. So we are going to wait for the experiment to finish. So we get 64% for experiment 6. Move on to experiment 7, where we use HGDM for the optimizer. We use 3264 and 168 for the filter sets, and we are using 1e-3 for the learning rate. So this experiment is going to take a bit of time because we are using such a deep filter set, or such a high value of filter sets. So this is going to be taking a bit of time to run. So we got 68% for our experiment 7. Next we are going to do experiment 8. Well, next we are going to do experiment 8, where we use this filter set, which is 8 163264, and we are using a learning rate of 2e-3. So we're going to run. So the learning rate for this experiment 8 is 0.002. So we are getting 69% for our experiment 8. Next we are going to do experiment 9, which we use this hyperparameters, which is 163264, and we use L2 regulation for this one. So our learning rate is 0.001. So we are going to wait for the experiment to finish. So we get 67% for our experiment 9. Lastly, we are going to run experiment 10, which we will be using this hyperparameter, which is 16, 32, 64, and 1e minus 3. Same with the master, which is the we also enable data augmentation. So our denominator is 0.001, and we are going to wait for this experiment to finish. Then we are going to see what is validation accuracy for this experiment. We get 68% for experiment 10. So among all 10 experiments, experiment 8 is the one that got the highest accuracy, which is 69%.
Okay, now we will do a testing for the British Shorthair. As we can see here, this is the coding where the top is for the training and the below is for the testing. So now we click run. Now we will wait until the training is finished and it will show the accuracy for the testing. Anjay. Okay, as you can see here, this is the result for the testing, and this is the original image that we do, and this is the generated image from the original image just now. And for the validation accuracy for this image is 65.50. That's all for the British Shorthair.
Now we will test for the Siamese cat. So this is the training progress. So we will wait for the training progress to complete it. Okay, as we can see, the validation accuracy is 65.50. Next for the figure 3, there is prediction. And next, we can it is generated the Siamese cat. And that's from me. Thank you.
So next we are going to test our new image based on experiment 8, which got the highest accuracy, which is 69%. So we are going to run this section to test our person image. So as you can see, the AI managed to figure out this is person with 51.3%. This is our original image, and then we resize it with to 100 by 100. So it also detect a bunch of other breed, but ultimately person is the one that is predicted. Yeah. Next we are going to test Maine Coon image. Again, we are going to run section. And then as you can see, our top 4 prediction. So the AI managed to predict correctly, which is Maine Coon, the highest, and it's also detect person, but it's lower. So it managed to detect 96% accuracy. So this is our original image. Then we resize it with to 100 by 100. So this is our network architecture for our CNN which is to detect cat breed. So this is our input. So in this example, we are going to take Siamese for examples, and then we have 4 feature map or filter set, where we have 8, 16, 32, and 64. And then all of it is using the same thing, which is conv2d, batch, normalization, and relu. So and then all the feature all the filter set is going to fit into the max2d pooling, and all of them is going to be fit into the flattened layer, where the flattened layer is going to fit into our fully connected layer. So the fully connected layer is our classification area, where it's going to be classified what is the output of our new image, and then it's going to show us the output using the softmax activation function, whether it is Persian, Maine Coon, British Shorthair, or Siamese. This is our probabilistic distribution. So that's all from us. Thank you.